Hello student, very good morning to all of you. I hope you all are very happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the Carbanion stabilization. What are the factors that stabilize the Carbanion that we have seen with the suitable example? Number first one, S character of the Carbanion. Second one, inductive effect. Third one, resonance effect. And fourth one is aromatization. These are the factors which stabilize the Carbanion that we have discussed. Now today at present what we are going to discuss, let us see over here, reaction involving Carbanions. Means whatever we have seen, method for the generation of the Carbanion, stabilization, factor stabilizing the Carbanion. Now the reaction involving Carbanions, and what type of the named reaction or the famous reaction which involving as a Carbanion or which takes place via Carbanion or which proceed through Carbanion, that we are going to learn over here. And Carbanion can in principle act as, this Carbanion can be act as, and we know that Carbanion is nothing but the carbon atom carrying negative charge is called as a Carbanion, and that negative charge it can act as Lewis base as well as or nucleophile. It can act as Lewis base, or it can act as a nucleophiles, right? Nucleophiles. And as we know that nucleophile and the Lewis bases having as a same, because Lewis bases is nothing but as a negatively charged species or containing as a lone pair on it. So that type of the capable of donating lone pair or negative charge, so that type of the species is called as a Lewis basis. And when nucleophile also has a negatively charged species as well as containing or having or possessing lone pair of electron, means they are having a similarity. They are the electron donor as well as they are negatively charged species, or the heteroatom containing as a lone pair act as this one Lewis basis as well as nucleophile. But there are three major differences that we already discussed in our previous lecture or in a previous semester also. Now here we are going to see Carbanion act as a Lewis base. When it will act as a, when we can call it as this species are Lewis bases and these species are the nucleophile. Remember here the Carbanion as a Lewis base. Number A, Carbanions as Lewis base. When it is act as a Lewis base, that we are going to learn over here. Carbanion are very strong Lewis bases, and if they accept a proton, they get converted into a neutral compound when that is called as a basis. For example, here let me consider over here. Here you observe this this structure carefully. What do you see over here? There is a Carbanion, and when it abstract the proton, it get converted into as a neutral molecule, right? Now, like this, and you are going to get here R CH2, and this R we can write for sake of convenience. This is a neutral molecule we got over here, neutral molecule, and therefore that time we can call it is behave like as a Lewis basis, because it has a tendency to donate the lone pair to the to the H plus ion and to form the neutral molecule. In a previous case we have seen OH minus when attacking with that H plus producing as a neutral molecule as a specifically water, and at that moment, at that time we can call it as a this is act as a Lewis base, right? Lewis base, they have a ability, they have a capacity to donate the lone pair to the H plus ion, and producing the resulting compound must be the neutral molecule. Then and then we can call that it is behave like as a Lewis base. Now the nucleophile addition reaction, nucleophilic addition reaction. Now in the B case, nucleophilic addition, nucleophilic addition reaction, right? Nucleophilic addition reaction. Nucleophilic addition reaction, what? This Carbanion as a nucleophile. Now here, just now we have seen Carbanion as a Lewis base, Carbanion as a nucleophile. Second one is a Carbanion as a nucleophile. Carbanions as nucleophiles. And that is a major difference between these two. Even though they having a similarities, negatively charged or lone pair having a ability or the capacity to donate the lone pair, but here the major difference when to call base and when to call nucleophile. Remember here Carbanion as a nucleophile. Now when they as let us take here, this is the example we have taken as a Carbanion as it is CH minor charge. These are, as we know that this is a Carbanion species, right? Carbanion, when that will be treated with alkyl halide, let us see here, alkyl halide, we know that it is an organic compound having as a general formula RX is known as alkyl halide. When this nucleophile attack or nucleophile is react with what we can call it this, if a Carbanion act as a nucleophile, a new carbon-carbon bond would be formed. Remember here, the new carbon-carbon bond would be formed over here, would be formed, and that is the speciality here. Now in this case what is happening, after reacting this Carbanion with the proton producing as a neutral molecule, but when it is act as a nucleophile, it produce or it form as a new carbon-carbon bond, and therefore this at that time or at that moment we can call it is a nucleophilic in nature, or it is act as a nucleophile. Remember here what is Carbanion, here also a Carbanion, here also as a Carbanion, right? But here act as a base, Lewis base, and here acting as a nucleophile. Remember here because when this nucleophile attacking on that R, because in this case R has a tendency or it getting as a plus delta charge, minus delta charge, there is a departure of leaving group, and we are going to get here RCH, R1 R over there, and here X minus charge, that is the leaving group, but here there is a formation of the carbon-carbon new bonds over here. New carbon-carbon bond is formed, and therefore this type of the reaction, this type of the reaction we can call it is act as a nucleophile. Understood? When to call as a nucleophile and when to call as a base. Remember the base when that negatively charged species forming the bond with that specifically hydrogen, specifically with proton, producing the resulting compound should be the neutral in nature. That time we can call it is acting as a Lewis base. When to call as a nucleophile, when that Carbanion attack nucleophilic attack, when Carbanion react with carbonyl compounds or Carbanion react with alkyl halides and undergoes substitution reaction, that is known as a nucleophile. It can undergo substitution as well as addition reaction, and therefore in this case we can call it as a nucleophilic in nature. When it is act as a nucleophile, when that carbanion reacts with the another species on the carbon atom, forming as a new carbon-carbon bond, covalent bond is formed specifically, and so that time we can call it as it is acting as a nucleophile over there. So this is the speciality of that carbanion. And now this carbanion can be divided as a nucleophile. It can undergo substitution as well as this nucleophilic addition reaction. It can shows nucleophilic addition reaction as well as nucleophilic substitution reaction. Both the type of the reaction it shows. Therefore, let us see what do you mean by the nucleophilic addition reaction and what do you mean by the nucleophilic substitution reaction. When nucleophilic let us see first one is a nucleophilic addition reaction. Nucleophilic addition reaction. Nucleophilic addition reaction. Let us see here as usual. Starting compound is a carbanion, as we know that the general RCH minus over there, and here R, that will be treated with the when a carbanion reacts with alkyl halide and undergoes the substitution reaction, and then it is called as a nucleophilic substitution reaction, nucleophilic addition reaction. Here when it is treated with carbonyl compound RC double bond O, let us see here specifically I am writing like this, or we can write as a ketone group like this, negatively charged attacking over there, negative charge form over there, R then this CH, R then CO minus. Here we can write one R over here, another R. There is a formation of the new bond over there, and this type of the reaction is called as a nucleophilic addition reaction. And second one is known as nucleophilic substitution reaction. Nucleophilic substitution reaction. And this nucleophilic substitution reaction, just now we have seen nucleophilic substitution reaction. What is that? When this carbanion as usual RCH minus plus suppose the RX alkyl halide, and this react with that alkyl halide, it producing RCH, R then C. Let us see here, this is R, this is a new carbon-carbon bond is formed over there, carbon-carbon bond, and therefore this type of the reaction is termed as or called as nucleophilic substitution reaction. So carbanion nucleophilic addition reaction, just now we have seen both type of the reactions are there. Nucleophilic addition reaction as well as nucleophilic substitution reactions are involving the carbanion, these reaction. And now carbanion in nucleophilic addition reaction. Now carbanion in nucleophilic addition reaction, that type of the reaction we are going to learn here. So nucleophilic substitution and addition reaction are very important in synthesis of organic compounds. In section 1.4 we will discuss the nucleophilic addition of carbanion, and in section 1.5 we will discuss the nucleophilic substitution reaction. Carbanion in nucleophilic addition, first one, let us see, first one is a nucleophilic addition reaction, or what we are going to see over here, the carbanion in nucleophilic addition, carbanion in nucleophilic addition reaction. Carbanion in nucleophilic additions. So in that we are going to learn here many famous reactions such as aldol condensation, Claisen condensation, Perkin condensation and Wittig reaction belong to this category, and a Carbanion adds as a nucleophile to the carbonyl carbon of either aldehyde or ketone or ester. For example, let us see Carbanion nucleophile. Just now we have seen this is a general species which is known as a Carbanion, because here the carbon atom, if you observe this species carefully, this Carbanion carries as a negative charge, and therefore this is known as a Carbanion or Carbanion nucleophile. It is Carbanion nucleophiles, this one, and it will be treated with a carbonyl compound mainly observed in aldehyde and the ketone, and therefore there is an addition reaction takes. Here carbonyl compound we can take here, there, and there will be the addition reaction. What is going to happen? This Carbanion is going to attack on that carbonyl carbon, and the resulting compound will be formed here, CO minus this one, and then this new bond are formed over there, and therefore this new carbon-carbon bond is formed, and therefore synthetically it is a very, very important one. And in all these reactions, a new carbon-carbon bond is generated, and hence very widely used in organic synthesis for the synthesis of different organic compounds. And now let us look at here the nucleophilic addition reaction. Nucleophilic addition reaction, one famous reaction, that is a aldol condensation reaction. We are talking about the nucleophilic addition reaction. Nucleophilic addition reaction, that is a aldol condensation reaction. Let us see first one is first reaction is aldol condensation reaction. Aldol condensation reaction. And this reaction, I think you are familiar with this reaction in your previous class. You already learned this reaction, aldol condensation reaction. What are the starting material? What are the criteria? What are the substituent? What are the reagent? What is the reaction condition? And what will be the product? So that type of the thing you already learned in your previous classes. But let me tell you, discuss here the full. The aldol condensation means what? The criteria or the what we can call it as a necessary. It is used for the synthesis of beta hydroxyaldehyde or the ketone, or alpha beta unsaturated aldehyde or ketone. That is a specifically over here, and under the influence of dilute base, or what we can call it as a dilute acid, 2 moles of an aldehyde or the ketone containing alpha hydrogen atom may combine to form a beta hydroxyaldehyde or beta hydroxyketone. This reaction is called aldol condensation reaction. Number 1, remember here the criteria, the prominent or key point required for condensation of this aldol. Let me tell you, aldol condensation, one is a simple aldol condensation reaction, another second one is a crossed aldol condensation reaction, and third one is a intramolecular aldol condensation reaction. But that intramolecular aldol condensation reaction has a specific scientist name is given to that, that is called as a Dickmann cyclization, because the aldol condensation or aldol, he synthesized 2 reaction only, and after that he the third intramolecular type of the reaction are carried out or done by the new by the different scientists, the Dickmann, and that's why name is given to that reaction is a intramolecular aldol condensation. Remember, for aldol condensation reaction, the key points over here, the key points to remember while in aldol condensation, the substrate must have, that is aldehyde or the ketone must have a alpha hydrogen atom. This is the first criteria required. At least one of the atom, the two molecule which containing as a aldehyde are the ketone, and then there must be as a alpha hydrogen must be there, must be alpha hydrogen atom, must means 100%. If there, then and then that type of the aldehyde or the ketone undergoes the aldehyde aldol condensation. It is related to as a aldehyde or ketone, this compound, because both are containing as a carbonyl group, as we know that. And as we know that this is a carbonyl compound, sometimes it is referred as a aldehyde or the ketone compound, sometimes referred as a carbonyl compound. And therefore in aldol condensation reaction, condensation means combined together, and there must be formation of the, so there must be as a alpha hydrogen atom. Second one is a dilute, or what we can call it as a 10% sodium hydroxide, or the alkali is generally used, potassium hydroxide or the alkali. Dilute alkali is required over here. Alkali means base is required for the abstraction of the alpha hydrogen, because adjacent to the carbonyl, whatever there must be two alpha hydrogens are required there. Here alpha hydrogen, but in addition to remember the at least one of the molecule must have a two alpha hydrogen atom, then and then that molecule undergoes the aldol condensation reaction. And third one is a condensation takes place. Condensation between there is a formation of the carbon-carbon single bond, or maybe as a double bond, means new carbon-carbon bond are formed. So these are the key points you should remember here for the aldol condensation reaction. And today we are going to learn here the simplest one is a simple aldol condensation reaction. Let me first take here the simplest molecule CH3 C double bond OH. Everybody knows that acetaldehyde, which is fulfilling all these criteria, because now how to recognize, how to identify alpha hydrogen, always remember adjacent to the carbonyl group. This is the carbonyl group, or this is the carbonyl carbon, this is a carbonyl oxygen, and now adjacent, look at adjacent carbon atom. This is the adjacent carbon atom, and this is termed as a adjacent carbon, always termed as alpha. Most of the students get confused. They are this is they are it seems to be as a alpha, so it is not the alpha, because this is a aldehydic proton, so it is not the adjacent one. Always remember adjacent carbon atom, whatever carbon atom carrying those hydrogen atom, they are called as alpha hydrogen atom. Remember adjacent to the carbonyl group. Suppose let me see over here CH3 C double bond O and CH3. Look at here, is there alpha hydrogen atom present in this molecule? This is acetone, common name, or 2-propanone, that is the IUPAC name. Look at, this is a carbonyl group, adjacent carbon. On the left hand side there is a carbon atom, on the right hand side there is also as a carbon atom, and they are termed as alpha, right? And therefore this can undergoes as a aldol condensation reaction. Let me suppose let us see here CH double bond O and then H. Does this molecule undergoes as a aldol condensation? No, it does not undergoes as a aldol condensation. Look at here, only one carbon atom is present, and there is no adjacent carbon atom, so there is no alpha hydrogen atom, so and no alpha hydrogen atom, therefore no aldol condensation reaction. Remember, instead that shows as a Kanizaro's reaction, and that we already learned in a previous semester. But here just now we have seen HC double bond O H, there is a no alpha hydrogen atom, no alpha hydrogen atom, no aldol condensation. no aldol condensation. Here it undergoes as a aldol condensation. Suppose as a benzaldehyde is there, right? Benzaldehyde, everybody knows the structure of the benzaldehyde, this one. Is this benzaldehyde undergoes as a aldol condensation reaction? No, again, because look at, this is a carbon and there is a nothing but here is a carbon atom, and this carbon atom has a 4 bond, 1, 2, 3 and 4, and therefore there is this carbon atom is alpha, there is a no alpha hydrogen atom, therefore benzaldehyde also not showing as a aldol condensation reaction. So some of the thing we will see later, or let me say some, suppose CH3, then here CH3, C double bond OH. Is this molecule undergoes aldol condensation reaction? No, because look at, no aldol condensation, no alpha hydrogen atom, no aldol condensation reaction. Look at, this is a carbon, this is adjacent carbon atom, it carrying 3 different methyl groups are there, no hydrogen atom present at alpha position, therefore no aldol condensation reaction. Suppose we have CH3, then double bond O, then here CH2, CH3. Does this molecule undergoes as aldol condensation? Yes, it has a alpha hydrogen. This is alpha hydrogen, this is also as a alpha hydrogen, and therefore it can easily shows as a aldol condensation reaction very easily or the specifically. This undergoes as a aldol condensation reaction. Suppose we have this type of the compound, CH3, then CH3, then C double bond O, then here maybe as a CH3, then CH3 and CH3. Does this shows as a undergoes as a aldol condensation reaction? No, because here there is a no alpha hydrogen atom, and therefore such kind of the molecule do not undergoes as a aldol condensation reaction. Now let us move on to the first one, what we can call it as a aldol condensation. If you see the molecule carefully, you come to know that. Now let us look at here CH3, C double bond OH, and then 2 molecule I am using. First one is a simple aldol condensation reaction, means 2 same molecule, and then that will be treated with the generally as a dilute sodium hydroxide. Here dilute means 2 normal NaOH are this one, that is a normal dilute solution NaOH. What type of the product you are going to get? You are going to get here not CH, I think here you are going to get the product only this one, CH3, then OH, then CH2, C double bond OH. This product you are going to get, and this is called as a, this alpha, this one is a beta. And look at here, if you observe this starting material substrate containing as a 4 carbon atom, right? 2 molecule of acetaldehyde means there are total number of 4 carbon atom, and look at, if you observe this product carefully, what do you see over here? There are 4 carbon atom, 1, 2, 3 and 4 at beta position, and look at, this is a carbonyl carbon, or adjacent carbon atom always termed as alpha, beta, gamma, delta and so on. Similarly we are, so suppose it is treated with, or he just heat it, what is going to happen? There is a elimination of water molecule takes place, 1 H from H and OH from here, and we are going to get the formation of this compound CH3, CH double bond, then CH, C double bond OH. This is, look at here, this is alpha, this one is a beta, and therefore such type of the compound is called as a alpha beta unsaturated aldehyde is this one, aldehyde, because there is a end, and remember aldehyde is always present at the end of the carbon chain. This group is called as a Fermyl group or the aldehyde group. This is alpha beta unsaturated aldehyde, and as we know that unsaturated means number of carbon carbon double bond is present over there. So that type of the species is called as unsaturated. So this is called as a simple aldol condensation reaction, means two molecule involved over there, and we are getting as a, this is called as a beta hydroxy aldehyde. Beta hydroxy aldehyde, and therefore common name of this compound is aldol. The common name of this compound is aldol. Aldol, he discovered this reaction first time, and therefore name is given to this reaction is aldol. That is a aldol condensation. Now this is a simple aldol condensation reaction. Now why I am writing as this product? Because I am knowing the mechanism, and as we know that mechanism is a language of organic compound, and if you know the language, you can express your feelings or whatever thoughts very precise manner, or you can put your that is a, so remember as a mechanism. Definition of the mechanism we already heard many time or discussed many time. A detailed study of sequence of steps which are involved in the conversion of reactant into product is known as a mechanism, and now we are going to learn as a mechanism. Once you understood as a mechanism, you already learned that one, but pay the attention carefully here. You will see here there are some steps are involved, CH2, then C double bond OH. I am here taking as a one of the hydrogen atom, showing specifically in this manner or in this way. I am going to show you the mechanism. OH minus, generally OH minus, where from it is coming? It is coming from the dilute NaOH, and I am showing over there. This you can say step number 4, right? Now what is happening? This base can abstract the proton from here, and when proton get abstracted, it leaving its bonding pair on that carbon atom, and therefore we are going to get here CH2 minus charge, then C double bond O, and this is a H. That is the species. Now look at this species, the negative charge present on the carbon atom, and therefore it is known as a Carbanion, right? This is a Carbanion, and that is what we are studying. This is the chapter's name, Carbanion and their reaction. This is one of the famous reaction which is Aldol. This is a Carbanion, and now this Carbanion, this is a delocalization arrow. You might be knowing as a delocalization arrow, meaning of that reaction arrow. This is a delocalized arrow, and the meaning of this, the two structure can be drawn, the delocalization structure can be drawn through two ways, or this structure you can show in a two different way. The negative charge comes here, and that resting negative charge on the oxygen atom we can show CH2 double bond C O minus over there, and this is a hydrogen atom. Now adjacent to the carbon-carbon double bond, negative charge present on the oxygen atom, that type of the species, organic species, is called as a enolate. This is a enolate formation, and as we know that enolate are more reactive, or what we can call it as a reactive than the Carbanion in this particular case. Now look at the step number 2 over there. In the step number 2, what is going to happen here? Let us see another CS3 C double bond O. For the sake of convenience, for the mechanism point of view, I am writing another molecule of acetaldehyde this way, so that I can show the mechanism, or you can see the mechanism clearly over here. O minus hydrogen atom. Now in the second step, what is going to happen? This negative charge again forming as a double bond with that oxygen atom, and this double bond now attacking on that carbonyl carbon which is electrophilic in nature, and the negative charge present on that carbon atom. And now what is going to happen here, this CH3, then this hydrogen I am writing like this, then O minus over there, and then here CH2, then again C double bond O and H, the aldehyde group retain as it is. This type of the alkoxides are formed in the step number 2nd. And now look at the step number 2nd, because this mechanism involves the 3 steps. Step number 1 involves formation of the carbanion ion, further converted into as a enolate. In the second step involve the attack of enolate on the carbonyl carbon of the first molecule and form as a alkoxide type of the compound. And in the third step, generally that is a protonation, which is called as the protonation. CH3 CH O minus over there, then CH2 C double bond O H, further it is treated with HOH, or here positive charge carbanion that type, and it will pick up the proton from here, and we are going to get the product CH3, then CH as it is, and then CH2, then C double bond O, and this H. This is nothing but as a aldol, or which is called as a beta hydroxy aldehyde. Here is a butanaldehyde, and therefore it is the 3 steps over there. Now in the 4th step, what is this aldol is very unstable. It easily lose the proton, and we are going to get the formation of that compound. Let us see over here, this one, or you can call it as a step number 4 also, doesn't matter. And now here how it is forming CH3, then here I am writing CH, then OH. For mechanism point of view, one of the hydrogen atom I am showing like this, then C double bond O, and then just by heating it, there is a elimination of water molecule. How the water molecule, from where the atom is removed, one hydrogen from here and OH from here, we are going to, why this, the driving force behind it, the molecule form which is a more stable one, and therefore we are going to get here CH3, then CH double bond, then CH C double bond O H. That is a crotonaldehyde. Crotonaldehyde, that is a common name of this compound, or sometime it is referred as alpha beta. It is known as a alpha beta unsaturated compound, alpha beta unsaturated aldehyde, or the common name of this compound is a chalcone. Remember, this is one of the, suppose as aromatic compounds are there, so that type of the sometime it is referred as a chalcone. So remember, so these are the this is a simple aldol condensation reaction. I think we have seen only as a simple aldol condensation reaction. In the next lecture we will see remaining one, cross aldol condensation reaction. What does it mean? What are the key points required for it, or the substrate, and intramolecular condensation reaction, why it is called as a Dickmann cyclization, that we will see in the next lecture. I think we have discussed the aldol condensation reaction and the reaction involving as a carbanion that we are talking in. Under that heading we have seen this one. I think with this let us stop today here. Thank you. Have a nice day.